So let's talk about now a situation where you would end up with a double or a triple bond, how you would use this total valence accounting to figure it out. And our first molecule here is going to be a formaldehyde, CH2O. Now CH2O has 12 valence electrons. So we've got carbon bringing in 4, each hydrogen atom bringing in 1, but we've got 2 of them, and each oxygen atom bringing in 6. So we have 6 plus 4 plus 2 will give us a total of 12 valence electrons. Once again, carbon's our central atom. We've got oxygen, 2 hydrogens, and we want to draw a bond to each of the periphery atoms. 1, 2, 3. From our valence electrons, we need to subtract out the number of electrons that are wrapped up in bonds. So we've got 3 bonds, each contains 2 electrons, and this will leave us with a total of 6 electrons left. Now we want to start satisfying the octets of the periphery atoms, but keep in mind, hydrogen doesn't want an octet, it only wants 1 bond. So we're only going to work with oxygen. We're going to work with oxygen until either we run out of electrons, or we see the octet, we've met the octet for oxygen. So we do 1, 2, 3, 4, 5, 6 electrons in oxygen. This will give us a total of 8 electrons in oxygen's coordination sphere. So we're going to lose the 6 of that, and that leaves us with no valence electrons. Okay, oxygen satisfied its octet, hydrogen's happy, but here's the problem. Carbon only has 6 electrons in its coordination sphere. It would prefer to have 8 by the octet. So what we're going to do is convert 1 lone pair on oxygen into another bond. So we're going to draw a second line, erase that lone pair, and now we have 8 electrons around oxygen, 4 in terms of lone pairs, 4 from bonding, and 4 around carbon, 1 from each bond. So we consider this the Lewis structure for formaldehyde. But let's draw something a bit more complicated. Let's draw a hydrogen cyanide. So hydrogen cyanide, HCN, hydrogen has 1 valence, carbon has 4, and nitrogen has 5. And this will give us a total of 10 electrons. Now once again, carbon's going to be our central atom. We've got nitrogen, we've got hydrogen, and we've got 1 bond to each periphery atom. We need to subtract out all the electrons we've tied up in bonding again. So we have 2 bonds, 2 electrons, and this will leave us with 6 electrons. Now we're going to fill up the valence of one of our periphery atoms in order to give an octet. Now again, hydrogen doesn't want an octet, just wants 1 bond. So we're going to go to nitrogen. So we've got 1, 2, 3, 4, 5, 6. Well, it's great. Nitrogen has satisfied its octet, but carbon now only has 4 electrons in its valence shell. So what we did with oxygen before was we took one of these lone pairs and we kicked it over into a bond. So we're going to do that now. Take our 2 electrons, draw another bond, and erase it. Nitrogen still sees an octet. We have 4 due to lone pairs, 4 due to bonding, but carbon is still beneath its octet. It's only got 6. So we're going to take another lone pair. We're going to drop it down and create a 3rd bond. In this case, nitrogen still satisfies its octet. We have 2 lone pairs, we have 6 due to bonding, but now carbon also has its octet. We've got 8 total electrons due to bonding. So this is how you're going to use the lone pairs in the periphery atoms to increase the coordination number and get the central atom closer to the octet. Every time you have your central atom beneath the octet, you're just going to take another lone pair, make another bond, and that's going to get you closer and closer.